So basically here we focus on the representation part. It is the, if you think about that, it is the basic step. You have numbers and you want to encode them visually. I will be very careful in that, step by step. I will discuss about the different kinds of data we have and its complexity. And I will show how to encode a single value, 2 values, 3 values, and how to deal with the multidimensional data. There is a part of this classes that will be devoted to dimensionality reduction, principal component analysis, TSNE. Maybe you are familiar with that from other classes. But I will do that in the direction of visualization, how to take advantage of that kind of dimensionality reduction for improving visualization. I will discuss how to encode relations, lines, map and diagram, about trees that are very special kind of representation. And we conclude all the means you have at disposal for representing data. Remember, here we are not thinking about the resolution of the screen, about the room. We are just encoding the data in a totally abstract virtual space. Let's talk a little bit more about data. You have attributes of data, and they are typically single values that might be numerical or categorical. A data item typically has several attributes. A single car has several attributes, as previous example. And this is typically represented by a mathematical relation among them. The relational model takes advantage exactly of this basic mathematical approach, a relation. If you look to attributes, you can discover some patterns among them, between them. Maybe a correlation, direct correlation, inverse correlation, or if you move to data items, you can discover patterns in their original space, like cluster, outliers. Or they can have a relationship. One item is connected to another item, the John's car, or to cars that belong to the same person, or whatever. So basically, we have the problem of representing single values, or representing relations or relationships visually, and you want to represent patterns and functions. This is the basic activity that you want to do. I give you some example, and after I go deeper in that. Single value. Assume that you want to represent a single value, the price of a car. We can use the position of a dot along a bar graph. And its position is resembling, if this is the interval between 12 and 14, objects closer to the left are in this range of value, objects closer to the right are in the range of 14. The same can be done, so it is the position of the elements, but here we have no details about that. If you put that on an axis, this is the most accurate way you can do that. The position of the dot gives you the exact value, numerical value of the car. You can represent it with the length. This bar length is representing 12. Or you can code it with the color, moving from 10, 11, 12, 13, or with the size of a circle. I showed you that there are some means that are better than others. This is the best solution, the position. This is the second position, the length. And after that, you can go for colors or size. This is in a hierarchy. of effectiveness in representing a single value. How to represent relations among values? This is a relational table. You are familiar with it. The physical position in this table represents a relation among values. These are all the attributes of a car: the price, the consumption, the rating, and the age of the car. Here, touching a dot, you can highlight a single value. Here you are touching this car, and you are highlighting one of these attributes. For here, we have a scatter plot that is presenting a relation between two values. One value is categorical. It is the picture of the car. The other value is numeric. But you can have numeric with numeric, as we discussed for number visualization. Brushing. Let's start with this image. After that, I will discuss the brushing. This is very simple. It is representing an hospital. On the left, you have the doctors. And on the right, you have the beds of the people ill in the hospital. Brushing is a very old technique that is defined by Bob Spence in his book in 2007. Basically, it's the process of selecting data items interactively, means doing something, typically with the mouse, but you can use also a touch screen. You can use any interaction means to select one or more data items from a subset. And initially, the original intention of brushing was to highlight a connection between different visualization. Here, even it is very simple. Here we have a visualization about the doctors, and we have a visualization about the beds. You don't know what is the doctor in charge of this bed and vice versa. Each doctor is in charge, is carrying a subset of these beds. You can highlight this relationship with brushing. You touch a doctor and you highlight the beds in charge of the doctor, or vice versa. You brush on the beds and you see the doctor in charge of that beds. And this is called the brushing and linking. Has been defined by Vogt in 2002, or a little bit before Spence, emphasizing that the purpose of the brushing is connect different views. We will see that several times, and I will show you that a typical InfoVis solution or visual analytics solution is composed by different views, 2, 3, 4, 5 of them. And with brushing and link, you can discover how the same data is represented in different views. And this is a very powerful means of analysis. So brushing is one of the main, the basic interaction technique that you can use. But this is wrong somehow, because if I kill the brushing, you don't see the relationship. If you can encode it visually, it's much better. For instance, here we have the doctors that are below the beds they are in charge for. And you don't need to interact with the system to see which doctor is in charge of which bed. Here we are encoding the relationship by spatial arrangement, the position basically. What about function? A typical way is representing a line, as you know from your study. This is a very classical way. Maybe with some confidence interval that in this case it was a regression, and you have the idea of how much is precise your story. Or you can use a scatter plot. A scatter plot is very good for looking correlation, regression, or whatever. For instance, this scatter plot provides us with insight that basically does not exist a correlation between price and miles per gallon. You see, low price corresponds to high and a little consumption. There is no a visual connection. So let's go to encoding single value. We already discussed the way to do that: position, length, colors, and so on. It seems quite easy, but there are some human factors that make this sometimes a problem, an hard problem. And according to the task of the user, again, you must consider that. And I really like the example provided by Bob Spence because it is about aircraft. I love aircraft. And the first idea is about just a single basic measure. The aircraft 8. It is a single value, but is very important, of course. Having an idea of your height on the ground is basic information for any pilot. And there are three problems with it. One is the scale of the measure. From historical reasons, even in Italy, we are using the feet. A single feet is very little, 30 centimeters. When you are flying, 30 centimeters is nothing. So the unit is too little. A pilot thinks in terms of hundreds of feet. And however, sometimes 100 feet are still not enough. For this reason, a typical physical altimeter is done using 3 ends. The shorter for 10,000 feet, the intermediate for 1,000 feet, and the longest for 100 feet. And to come up with the total number, you have to combine them. So you see that you have 10,000, 3,000, 460, you combine them to have the final number. It's not so complex, but it's not intuitive. You will learn very quick to use this. The second problem comes from what is called the change blindness. Change blindness is a limitation of our brain and our eyes that makes us not able to perceive little difference between two situations. For instance, if you have this image that is representing 32,600 feet, and you compare with this, in which just we swap the 2 ends, you can confuse them. They are quite similar, even if they are very different in meaning. You are 3 kilometers lower in this case. This example is not very good in the sense that if you're flying physically, you cannot move from this high to this high without perceiving physically the difference. But if you're using a flight simulator on your computer, you don't have physical stimulation about what you're doing. If you move your side, looking something on the right, your back, this is change. Maybe you don't perceive that. This is called the change blindness. And I show you some way to overcome it. Look at this. Animation can help a lot. You will see that the D3, the system for having visualization on the web, that will be the basic part of our classes for giving you practical means, includes a simple bullet for asking, give me an animation. Each time a visualization changes, you can ask that happen with an animation. If the animation helps you to keep track of what is going on. Second point is your mental involvement. If you are flying, maybe you are in situations that are not dangerous, but are using your brain. And you have a lot of instruments here. Maybe you are looking to some of them and you don't perceive some changes here. And that can be very complex to deal with. Here there is an example of an altimeter for a glider, Italian glider. It is easier to use because you have only two ends, one for kilometers and the other for 100 meters. But a big risk, and it happened, is the unit. If a European pilot uses this, is not aware with the meter, and vice versa. There are also other problems involved in it. So units are a problem, conversion may be a problem, stress can be another problem as well, and change blindness is a problem as well. According to the task, you must think about that. If the task is just analyzing a lotto game, you are not under stress. So you don't need to think about the brain of the user or whatever. If your task instead is doing something that is involving your energy, or you can be involved in some challenging situation, you must help the user. All this long story. What is the actual solution? Now all the planes are equipped by electronic means, and this is the typical solution in all the cockpit of the airplane we used to move around the world. You have a unique scale, providing the overview, or starting from the ground to the top of your height for the flight. And this is representing your position. So give you your point in the story. And these two big digits reflect the pilot's mind. They represent hundreds of feet. Here you cannot be affected by change blindness. If you move your eyes, your back, the position of this element will give you a clear indication. You have a double encoding. This is another point that I will stress in other visualization. Sometimes it makes sense to double encode the same value. Here, this value is encoded here as either as a position here. The position is encoded. Okay, I am a little bit above this value. And I have also the digit here. So I can read them twice. You will never be fooled by this kind of altimeter. This is a simple solution that is available only because we have a modern planes, because this is totally mechanic. It does not use electricity, and it is on glider, and most of the basic avionic plane are still using it. If you go on a jumbo, you will get something like that. Back to the support from the user about heavy situation. This is an example from a medical environment. Maybe you are a surgeon. You're doing some complex activity on doing something with the body of a person, and you need to have the control of all vital signs, the heart rate, the pressure, or other indication. And you are also involved in other activities. And a surgery can be very long. And you are tired, you are stressed because you're doing something that is important. And in this situation, it's very common to help the user with additional means. typically using the sound. For instance, a beep, you see that in the movie, a beep representing the frequency of the Earth can be noticed also when you are doing something else. You can perceive very easily the change in the frequency of a beep. Because the sound is a totally orthogonal means for perceiving information. There is a little bit of activity in InfoVis to use this channel for encoding values, but this is very preliminary. We are not big results for that. Encoding numbers with sound is something that we are not able to do. We can encode frequency. If you have beep, 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 you can perceive the difference. But the main point is that sound is very good in changing your attention. An alarm raises your attention. A change in the frequency raises your attention. And it is so strong, the involvement in your perception, that very often a pilot is going to turn off an alarm in an emergency because the sound is disturbing. You experiment that even in a class. If I am talking and a car goes in the street, the noise of the car is disturbing us. It's not touching the visual part. You see the screen on my back, but the noise is disturbing you. And a nice example is that in emergency, pilot typically turn off the radio because having to chat with the control may be really disturbing. If you remember the terrific story of the landing of the plane on the water several years ago, the last message was from the pilot was, "I'm turning off the radio. I have something to do else in this moment. I don't want to be disturbed of that." What does it mean for us? Forgetting the planes, is that sound and animation is something that can help you to fight this kind of problem. Let's back to the change blindness. Change blindness is something that is used very often in comics or magazine to find out the 9 little differences between two images. Here there is an example. What is the difference between this plane, if any? You have 2 pictures. Do you get the difference? You have to expect it. Someone of you are very few in the class. Someone of you will be able to get a difference, someone will not. But this is a clear example of change blindness. You have 2 identical images that differ for just a detail. And that detail does not come up very easily. You have to expect it. Find the difference between 2 pictures. If they are very similar, but a single element requires inspection. Meaning that if you're observing a visualization, just a little element changes, you don't notice it. For this quiz, the answer is that I prefer the first one, because if it is not a glider, I really like engines. The second plane is missing the engine here. And you can see how animation can make that very evident. If you, instead of taking away the engine, you have an animation that makes it disappear slowly, you notice the difference. The idea is anytime you do a change in visualization that is complex, you can use animation to take the user attention on that part of the image. Otherwise, you lose this information. And let's go for another kind of blindness. Maybe that you are familiar with this movie. It's very old on the web, but however, let's go with this experiment. Here we have a movie in which we have some people that are launching a ball around, knocking it on the floor and passing. Among them, there is only one unique girl with a white shirt. You have to just to count during do that really. I will start the movie. You have to count how many times this girl gets the ball and throw it away, disregarding if she knocked the ball on the floor. If you're ready, I go. Okay, the video is over, and I want your opinion 6 times, 7 times, 8 times, 9 times. What is your answer? Even by the shot, how many times the girls got the balls and threw it away? You have an opinion? Did you count them? How many? 6. 6 times. Okay. What about you? 6 times. Good. But I have another question for you. How many gorillas were in the screen? Did you see the gorilla? 1. You 2? Okay. For people, let me see in the chat. Okay. they know that it is in a very old people also spoken in the microphone. It's like do you hear me now in this moment? Yes, okay. If you look at the same video without being distracted by the girl with the white shirt, you will notice in a moment that there is a gorilla inside the video, knocking on the chest and going away. And typically only 10%, 15% of people notice the gorilla. The 80% is so focused on the girl with the shirt that is not noticing the gorilla. And this is the typical way in which a magician does the trick. I move my hands here, you look at my hand, I do the trick with the other hand, I distract you in this way. This is called the inattentional blindness. It's a well-known psychological behavior of human beings. If you focus your attention on a part of your scene, you don't perceive what happens outside. And again, this is something that happens with the complex visualization. If you're looking at an image and you are focusing on something on it, like even let's say, for instance, this is very typical. You're flying, you look for the compass, for the direction, the bussola. You want to see, you focus your attention on that, for having the bear that is precise for 1 degree. You don't see what happened on the right. And you can have something changing here. You don't perceive it. You can have a fluctuation, something that, like a gorilla going through the screen. And again, animation is a very good way to overcome this problem. So animation is not for fun. It's not for being nice. Animation is a way to convey your attention to what is changing. If this gorilla, okay, in the screen was blinking, 100% of you will get it. Even if you're looking to the girl with the white shirt, because your attention is distracted by the blinking animation. This is the point. Apart the fun from the gorilla. And I still remember, sorry for that, but it's a nice remembering of mine. A long time ago, I was in a conference, and Bob Spence, the author of the book, was arrived with this video that it was totally new. And he was so enthusiastic, connecting people to show the movie. And I saw, I didn't see the gorilla, and in a classroom, typically, 80% of people, 70% do not perceive it. Okay, be back to the single number. Sometimes you want to see a collection of numbers. You have a single value, like the price of a car or whatever, but you don't want to see a single value, you want the distribution of the values. So a collection of numbers. A typical way is to having a scatter plot, a multidimensional scatter plot. You just plot the points corresponding to the values. And this is very effective because the density of these points give you an indication. You can perceive very quickly that here you have a density of cars, here another density, this is an outlier. Very, very, very high, very costly cars or very cheap car. Or you can use a box plot. We discussed that in the example of the lotto game. A box plot is aggregating that visually. You have the median, you have the percentile, and if you want to go for that option, it's not mandatory, you can have also outliers. There are some formula for computing them. Here you are plotting the original value. Here you are deriving new data. This is an important point. Very often in the visualization, there is not only the original data. There are new numbers, new values. This median here, that is about, let's say, 29, is not the value of this data set. It's something that is computed. The same for the upper lower quartile. And sometimes you add some value to the data. In this case, to describe in a compact way the distribution. And you can see how this scatter plot, sorry, this box plot is somehow representing the data distribution. You see, basically, you have this value here, you see half above and half below. You can see high density here, that correspond to this part. That these are outliers, are above the maximum. And here is the point. I don't know if it's a real point. No, okay, it's a real point on the screen. Here, as an outlier. So this is a way for representing a collection of numbers. And according to the task, that might be the point. Remember the lotto game, the example we did. Remember the distribution of the warehouse sending parcel and the shipping time, the delivery time. A collection of numbers can also handled by bar graphs, as we did for the cars. Here, the length of the bars is representing the number of elements inside. And be careful of the scale. I don't like the scale. This is the example of Bob Spence. He is a friend of mine, and he's a very good person. He did a lot of work in visualization. But I don't like this example because it is ambiguous. Where is 20? Here or there? You don't know. So you need to overcome this problem somehow. Even here, 12 is both here and both here. You can guess that it is not included, but you need a way of specifying it somehow. Or you can go You remember the example for this? Oh, sorry, this is a bar gram representing the categorical data. Here, the length of the bar reflects the number of Nissan cars around. You can see that you have more Ferrari than Nissan, and you have more Cadillac than Ford, and so on. And the Ferrari and Cadillac are more or less the same. And that raises another point. What is wrong with the bar with respect to the original idea? Here you have an histogram, you have a bar. What is that is wrong here? That give you a confirmation about the ranking of the visualization for encoding numbers. Which one is longer, Cadillac or Ferrari? You're not able to answer. If I flip them vertically and they put on the screen close each other, you will notice having a very little difference. Why? Because when you are comparing, for instance, this, they are the same, but I will go in the chat. Okay, good. Answer from the chat exactly to the question. When you compare this with this, you are really comparing the length. We are not in representing a number, they are good enough. You can estimate, I mean, if you have a unit, you can understand how many items are here, the number. But here I'm talking about the difference. Perceiving the difference is easier if you look for the position. Let me, I cannot use, oh, I can, maybe I can do. Not here, I have to go outside the presentation. I want to show you what I mean. Maybe you still see the presentation, Tom? Yeah, let me see. Okay, thank you. I'll show you my point with PowerPoint. Let me go for some drawing here. No, it's not. Okay, yeah, they are. Okay. Look at this example. You can easily perceive that the right one, apart of the, I want to make it equal as a that the right one is a little bit longer than the other. Why? Because you have a baseline here, and you are comparing the difference between these two positions. So to assess to discover the point that this one is longer than this, you are not comparing the length. You are comparing the position of the top. Position is more effective than length. If I just take this and I rotate them, I'm not changing the length. Side by side, you will never come up with this information. Unless I put it in this way. And again, you can see that the bottom one is longer. Position is more precise for human beings than length. So if you want to encode a number, you go for position. Use length as a second choice. If you want to compare elements, position is the better situation. And even if you think that you are comparing the length, you are not comparing the length. You are comparing the position of the, if I just move it, again, you lose this information. These are very simple points, simple knowledge about perception. I will go deeper in that discussing the Colin Ware book. But without this information, we are going to produce bad visualization. People do not think about that. People is not aware of that. You will learn to design visualization, taking into account this kind of problem. And let me back to the, I read this for remembering this note. Okay. So, frequency distribution, we already saw it. We have representing a collection of number, either with the frequency of elements in a bin, or using a shape interpolating. We saw some example in number visualization. Both solutions are good for depicting a collection of numbers. And basically we are done with the single values, and we move to two values. How can you represent two values? The king of the visualization for that is a scatter plot. All of you are familiar with the Cartesian plane. Use that from the basic school to represent function, drawing example. Just you put the values on X and Y, and you have a dot representing the elements. And for instance, here you can easily get, here the example, now we are moving from cars to houses. The unit is still sterling because Bob Spencer is an English person. And here each dot is an house, and its position represents the number of bedrooms and the price of the house. Here we have the data set in a numerical form with the relation among these two attributes. And you can see easily that you can get a sort of line here. There is a correlation. The higher the price, the higher the number of bedrooms. But you have some outliers. Here there is a very cheap house with a lot of bedrooms. Maybe it's a little hotel. Someone that took is a house split it in several rooms for sleeping, or it is something wrong in the data. In any case, it is an outlier. Here instead we have very expensive cars. Very expensive houses that still have only one single bedroom. However, the data is somehow in this way. You can perceive the trend, the correlation. This is a positive correlation. And a special case about that is the time. This is a typical line. You are familiar with this representation. Here we have the time. The time here is represented in weeks of the year, from 1 to 52. And this is the price of a special stock, fluctuating up and down. And this is typical for market analysis, for medical analysis, every time in which the time is important. And there is a brand, not a brand, a part of InfoVis that is strongly dedicated to time series. And another part for geographical information. They are very strong because they are peculiar. You need special means for them. If you move from one single stock to 1,000 stocks, that would be the result. and you have a very crowded situation. Outliers are still visible. This is a very high priced stock, very stable along the here. Here there is one that is going down, maybe we lose the here there is the average, totally crowded. This is a typical situation in InfoVis. And you need a way to, you get an overview, but you cannot distinguish here. One possibility is to apply some sampling, use some colors, or for instance, to filter the data. And here there is a nice example of brushing. You go here, you brush, this is a typical way you draw a rectangle, and you include in the result all the lines that are in this rectangle. And here we are selecting both in time and in money. Here we have an interval in money between $70 basically to 250, something like that. And you are touching the first 4 weeks of the year. And you can combine them visually. You go here, you do another brush, and you select the stocks that after sometimes in the week between 7 and 12 are still in this range, and so on. This is a typical interaction that involves two quantities. One is the time, and the other another value. In this case, it is the price, but you can have other stuff. And you can take some kind of analytics. You can have some quick filtering mechanism, like draw a line and ask, give me all the lines that are similar to this, very high in the initial part of the year, and decreasing continuously along the time. It's not trivial. I mean, you need something that is not immediate to come up with the answer to this question. And there is a strong point that time is cyclic in some sense. You have the year moving from January to December. What do we have here? Here we have an information about the ozone level in Los Angeles from 82 to 91. Here we have the time from January to December. You cannot read it, it's very bad, the resolution on this image. And you have 82, 83, 84, and you have all the images aligned at each other. So this part corresponds to January. Each single dot is a day of January. The unit is a single day. You have 30 dots and so on. And you can easily compare. You can see that the color is encoding the quantity of ozone. It has the highest part in the hot weather. In June, July, and August, we have the maximum of it. And you can see that this is common year by year. But you can also compare that vertically. And you can see that this value still the highest in that single year, but it's decreasing. Typically because of pollution. So basically, the idea is that if you are interested in cyclic aspect, you can arrange the visualization in a way that allows to perceive patterns that happen in the same period that you are looking at. And maybe that this is another example. This comes from a work of Enrico Bertini, an old PhD of mine that we still share slides between us. He's teaching InfoVis in New York in this moment. This is about the traffic on a network along a day. The day is along the circle. You cannot read it, but this is midnight, 1, 2, 3, 4. This is exactly 24 hours of the day. And each circle is 1 day of the week. So we have Monday, Tuesday, Thursday, and so on. And you can see here it is, let's say, 6 in the morning. You can see how the activity starts here. The dots are representing the traffic, the IP packet in the network. You can see that here the office wake up in the morning. Someone starts the procedure for the basic databases, whatever. Here there are people working during the day, and here there is the end of the day. It is in the afternoon, 4 or 5 in the afternoon. The activity stops, and you see that there are patterns. Every day at this time you have a strong traffic, and there is some analytics that is helping you. These yellow dots are added on the visualization by some computation that highlights something that is very repetitive across the days. And this view that is about 1, 2, 3, 10 days has been filtered by a longest view. Here we have a timeline you see on the bottom. Here the time is on the x-axis. You cannot compare the same part of the day, the same hour, or the same days, Monday with Tuesday, whatever. Arranging the time on a circle allow for that. And the goal of this story, if they were successful, is to discover someone that during the night was stealing some data. Every day between 9 and 10 in the night, there is an intense traffic. It was an employee of this company. He was stealing data from the company to sell some information outside. And this is a nice way to arrange time when you want to see the cyclic part of it. Is that so new? You remember this? I'll show you the first class. Long time ago, Florence Nightingale got the same idea of arranging time in a circle. But she was not good enough in daring to overlap the same time in an expanding circle, like here. If she did that, you can easily compare a value of a month with the value of the month of the next year, like we did here. You can compare the same month year by year. But the idea was there, using a circle to arrange time-oriented data for repetitive pattern. This is very powerful. I put it on the table, but I will continue tomorrow because it's enough for today. Having a circular or spiral visualization is done not only for highlight repetitive patterns, that is very powerful, but also to save room. Just this example. Here, there is some data, and there is no regularity on the radius. So they are not reflecting the same period of the time. But the point is just to have this arranged in this way, because if you put that on the x-axis, it will not fit on the screen. So circular radar encoding is used either for repetitive patterns or for having more room for the data. And if you go to this link, I will put a slide on the web today, you will get a lot of other examples. But I will discuss that by deepening it by tomorrow.